Making robots should be easy. But what's better than easy? How about reliable, repeatable, and easy? Last episode, we built this robot out of a bag of tricks. Loose wire, hot glue, 3 tools, and an evening. And it worked. Today we're putting the tricks away and applying some solid engineering to Caster's electronics. Starting with the star of this episode. A custom printed circuit board. I call this little guy the mini core. You'll be seeing him a lot around here, so we're not going to get into him today. He gets his own episode. Today, we're going to focus on printed circuit boards in general. 3 things. How can a hobbyist make their own? That's number 1. Number 2, what does it look like to solder one together? We're going to do that. And then finally, we're just going to drive this little guy around. And while we do that, I want to show you some of the code that makes him move. Let's get into it. It starts with a schematic. Every board starts with a schematic. This is the part people sometimes skip, but shouldn't. A schematic isn't a drawing of your board. Nothing's to scale. Nothing is where it'll actually end up. A schematic just says what connects to what. This pin to that pin, that's it. So why is that step 1? Because it's a prerequisite to deciding what goes where. Working out where it all physically fits is a completely different job. I've tried doing both at once. It doesn't work. So now that you have a schematic, it's time to get confident that it works. Prove it before you spend money. Ordering a board like this is cheap, but it isn't instant. You send the files off, and days later, you find out if you got it right. So look at what I already did. Every connection on that schematic, brain, driver, motors, eyes, voice, power, I'd already built it in loose wire, and I'd driven it around the room for the whole episode last time. That tangle is the prototype, and that's what it's for, a prototype. You can do it the way I did it, or you can use a breadboard or a proto board, or the mess of jumper wires that I ended up using. It's all the same idea. Build the circuit cheap and change it while it's still cheap. So let me give you an example. One mistake that I made personally. See how you have the pinout on the back of the ESP32? Well, if you apply that pinout in this orientation to your finished board, everything's mirrored, which actually means applying 5 volts to GPIO 5. That could be really bad. And I made that mistake. So it's just important to prototype. That's all. Now the other problem. Where does it all go? A board is layers. Copper. That's your wires. 2 layers, one on the top, one on the bottom. Then a mask over the copper, which is why boards are green, with openings where you want to solder. Then silkscreen. That's the white writing, and an outline that says where to cut it. And one more that people forget, the drill holes. It's just a list of every hole and how wide. You export all that, and you get a folder of Gerbers. Gerbers, that's the word to remember. A Gerber file just says put copper here, It's ancient, it's boring, and every board house on earth reads it. Zip that folder. That's what you send. Which brings me to today's sponsor, and the reason I have a board in my hand at all. PCBWay. They're the ones who made this board. PCBWay does PCB prototyping and assembly, and also 3D printing and CNC machining, which is handy when the board and the thing it bolts into are the same project. You'll see why later. Here's the whole ordering process in real time. You click Quick Order, add your Gerber, and PCBWay reads it. Size, layer count, hole count, all of it, straight off the Gerbers. It even renders a picture of your board, which is the first time you get to see the thing. Then you pick from the options PCBWay gives you. For a board like this, you change almost nothing. 2 layers, 1.6 millimeters thick. Pick a color if you want. There's the quote. You see I'm getting 5 because 5 is the minimum. Into the cart, address, pick your shipping, done. And then PCBWay engineering team looks at your files before anything gets made. They caught nothing on this one, but they've caught some of my mistakes in the past. There's a PCBWay link in the description. Register through it and you get a $5 coupon on your first order, and it helps me out. That's the whole arrangement. What do you do then? Then you wait. Mine came in 3 days. I'm not going to lie. This is a weird feeling. Last week, this was a file. Now, it's a board, and it's exact. The writing is where I put the writing. The holes, where I put the holes. Everything's labeled. Ports are numbered. And the name minirobo, which is pretty cool. Okay, but before we solder anything, this. This is a jig. I designed it and printed it. And if you don't have a 3D printer yet, you can order this jig from PCBWay when you go to order the board. And it's the reason I get to say repeatable and not just easy. Here's the problem it solves. There are 13 connectors on this board. Between them, 59 pins. Freehand, that's one connector at a time. Each one held square with a finger. You're also trying to keep away from a 500-degree iron. So, instead, every part just drops into a pocket. No little holes you have to thread pins into. A wide opening you drop a part into. Threading 28 pins into 28 tiny holes is miserable. And one bent pin stops the whole job. They're all recessed with the same depth. So the tops all line up. The board goes on and lands on the connectors. It doesn't touch the plate at all. Oh, and the board goes on face down. Every connector mounts on the top and solders on the bottom. So the side you're soldering has to face up. Roll it over the long way. USB ends on your left, port row nearest you. Then it's one pass. Same joint as episode 6. 59 more times. Heat the pad and the pin. Feed the solder into the joint, not onto the iron. One part that isn't a connector, this capacitor. It lies on its side under where the motor driver goes. Bend the leads a couple of millimeters out from the body, not right at the seal or you'll crack it. And that's everything soldered. I could do this again tomorrow and get the same board. That's the whole point of the jig. Then the expensive stuff just pushes in. Brain, driver. That one goes in one way. There's a dot on the silk screen for pin 1. Boost module, motors on their header, eyes into 2 ports, voice into another. None of it is soldered to anything. All right, let's turn this guy on. The firmware runs a self-test when it powers up. I'd steal this idea even if you never build this board. It walks everything on the robot, one at a time, and names each one on the console as it goes if you have it plugged in to the console. Three-second countdown, and that countdown is the eye test. Blue fades up and down, then red, then the disc sweeps from 2 kilohertz up to 5. That sweep does 2 jobs. It proves the voice works, and it's a tuning pass. A bare disc is loudest at one particular frequency. So whichever step sounds loudest to you, that's the note you want from the horn. Then left wheel forward and back, right wheel forward and back. 6 things checked in 12 seconds. And if something's dark or silent, I know exactly which port to go look at. Good time to say this. If you want the Gerbers, the schematic, the printed parts, the firmware, the jig, it's all free when you join the minirobo community at minirobo.io. That's minirobo.io. Link in the description. That's the robot noticing. There's a heartbeat running underneath all of this. If it doesn't hear from the pad for 0.4 of a second, the wheels stop on their own. The 4 face buttons are the 4 moods from episode 6. A is excited. B turns his back on you. C, you've met C. And D leans in. Oh, and this. The brain pulls right out. Goes into the next robot. Try that with the Tangle. Okay. While it's driving, I want to show you 2 bits of this code. Not all of it. 2 things you can steal. First one. This is the habit that'll improve every robot you build. If you take one thing from this section, take this one. Remember, the self-test, when we turn it on, that code is full of this. And that's completely fine. Nothing else in the robot has to happen during a self-test. Fade the eye. Wait for milliseconds. Fade it again. Nobody's driving. But put that same line in the loop that runs while you're driving, and it stops being a wait. Now it means nothing else in this robot happens for that long. Not the motors, not the radio, not the thing that stops the wheels when the pad goes away. So there isn't a single wait anywhere in these moods. Each one is written as a question instead. This performance started 340 milliseconds ago. Where should the eyes be right now? Where should the wheels be? So I can stop asking at any point. There's nothing to unwind. Nothing half finished. No timer to cancel. Last one, smallest one, and it's fun. That's the whole function. It squares a number. On the left is an LED fading up in a straight line. Even steps all the way up. And it looks wrong, doesn't it? It jumps bright almost immediately, then just crawls. That's because your eye isn't linear. It's way more sensitive down at the dim end. So an even ramp of power reads as a jump and then nothing. Square it first, and it breathes. One line, every fade in this robot goes through it. There were 2 boards in that box because right now I'm driving my robot with somebody else's controller, and I can't have that. Same brain, same ports, 2 sticks, 4 buttons, and it talks to Caster directly. No router, no phone, nothing in between. That's next time. Everything from today is free. The Gerbers, ready to upload. That's it. The jig and the firmware, including both things we just looked at. Join the minirobo community at minirobo.io, and it's free. Thanks to PCBWay for making both of these boards. And if you send off your own first board because of this video, I want to hear about it. Let me know in the comments. See you next time. Let's build something.